buoyancy. So, buoyancy. When an object is immersed in a fluid, the pressure on the lower part is higher than the pressure on the upper part. Since pressure is force over area, which you know, the more pressure you have, the more force you have. Okay, so moving along here. Now, the buoyant force acting on this submerged object is the sum of all the forces. I would recommend looking at page 328 for the derivation of this because it's too much to put in just this video. But the buoyant force is equal to the density times the volume times gravity. So buoyant force, FB, is equal to rho, the density of the object, times the volume of the object times the acceleration due to gravity. Now, here's a note. Because density is mass over volume, rho times V is actually the mass of the fluid displaced by the object. This is gonna come back in a few minutes here. But anyway, if you look at it, the buoyant force pushing up and the force pushing down are not equal because of this pressure down in the bottom. The last video we talked about how the deeper you are, the more pressure there is. And so that's why you have a bigger upward force than you do a downward force. And that is called the buoyant force. Okay, Archimedes' principle. A fluid exerts an upward buoyant force on a submerged object equal in magnitude to the weight of the volume of the fluid displaced by the object. Okay, let me say it again. A fluid exerts an upward buoyant force on a submerged object equal to the weight of the volume of fluid displaced by the object. Let's take a look at that in a little more detail. Okay, so for example, you got an ice cube or some other object floating in a liquid like water. The buoyant force is equal to the weight of the object. That's basically what Archimedes' principle is talking about. And the fluid displaced by that is equal to the weight. Okay, so that fluid displaced is going to be equal to the weight. Okay. Now, let me get this out of the way. Note, objects float when they have a lower density than the surrounding fluid. How can a steel ship float? Well, you know what I'm talking about, aircraft carriers or boats, basically any ship that's made out of metal. And so how can it float, you might ask? Now, if you know, or if you recall that the density is mass over volume, the ship has to have a large enough volume to lower its density because metal is heavier than an equal volume of water. So you need to increase the volume. So because most of the ship is filled with air, the average density is less than that of water, and that's why the ship floats. So basically, when you look at the cross section or front view of the boat, most of the inside is filled with air. And so that volume has to be big enough so that the average density of the whole ship, including the air inside of it, is less than that of water. Okay, specific gravity. It's the ratio of density of the object and the density of the water at 4 degrees Celsius. You might ask, why 4 degrees Celsius? I think I've mentioned in previous videos that water reaches its maximum density at 4 degrees Celsius, which is why ice floats. So specific gravity is equal to the density of the object over the density of water at 4 degrees Celsius, or rho over 1,000 kilograms per meter cubed. Now, the concept of specific gravity explains things such as why we only see the tip of an iceberg. Anyone who's seen Titanic knows what I'm talking about. But this is the important thing. It's more relevant to the book problems than the AP test. Specific gravity is not on your equation sheet. And so it's, I don't think you're going to see any specific gravity problems on the AP test, but if you're doing problems in the book, they may refer back to specific gravity, so you got to know what we're talking about. All right, Ninja Squirrel Productions, that is buoyancy.